Hi, my name is Akan. I'll be making a presentation on Tesseract AI. So, the intention of Tesseract AI is for it to be like a decentralized platform for storing genetic data. It's quite similar to, it's quite like the decentralized platforms like 23andMe and Ancestry, but the only difference is this one's data is going to be stored in like a decentralized way utilizing Avalanche subnets, and then I would be adding other key features on top of it. So what really makes this, what problem it tries to solve is in terms of like privacy concerns and also security risk, because we do know in the past, like I think there was a hack in like 23andMe where someone was able to get access to people's genetic information, and also we tried to create a financial incentive model on top of it. This is like the white paper that explains everything. So we'll be utilizing Avalanche subnets to deploy the basic smart contract that helps with managing um, data storage, and also we also created like a data marketplace that handles all of that. Then we minted each and every single data, genetic data, as ERC115 token, and integrated it with Chainlink VRF to make them truly unique. The intention is to also store this genetic data permanently on Airwave, which we're still trying to complete as of the time of making this video. And it's a custom subnet, and the code for its customizations are found on the GitHub repo, which I will be talking about. Then the data marketplace, we implemented what we call a reverse bonding curve, which is really, really simple, not as complex as what you will see in Bancor. But we did also go ahead to create a proper bonding curve contract, as in the future we would like to create like a financial incentive on top of it. And then also the intention is to integrate it with Cartesia and deploy what we call Cognito VMs, which would handle certain deep learning tasks. It could be like predicting the risk of a certain person ending up with a certain disease condition in like the next 10 years, and I would be using Cartesi to implement that. And or using Chainlink. Everything is well explained in like the white paper. Now, in terms of like the code itself, I used like a Yarn monostructure repo. And so this is basically the front end code and the contract. I'm going to show you quickly on the contract, try to write some tests for it. So it's like it uses like a diamond structure. So like this is like the main bonding curve contract. This Yeah, and this is like the main Tesseract contract that deals with permission, giving out permissions and revoking permissions also. And this is like the main pool contract. It's not like a classic marketplace contract where you actually transfer your genetic NFT data. What it just does is it grants permission to access, and the intention is you should be able to revoke this access. And in terms of like my Avalanche configuration, this is like my custom Genesis. I also tried, this is like the VM for Cognito, which is like the Cartesi engine that we will be developing in the coming weeks, where you'd be able to take your genetic data stored on Airweave, pass it on to Cartesi engine, and be able to run certain deep learning models on it, and then do some extra work on your genetic data. So it's supposed to be like an all-inclusive platform in the future. And this is like a an API gateway, which is not fully done, because the intention is not to be able to make these calls directly from the front end. So having a middleware that handles everything in terms of like routing and load balancing. More information, everything can be found on the GitHub, which will be included in the submission link. And you understand also there's a nice conclusion here that explains why we're doing exactly what we do, the problems we intend to solve, and the future. Thank you for giving me the opportunity to build my idea in this hackathon. Thanks. Thanks Chainlink, thanks Avalanche.